Okay, so let's look at, so we've seen now sort of what the displacement fields look like and that they make sense, so we can interpret them correctly, what we would expect to maybe see and what we're seeing from the finite element solution. What I mean, what I expect to see from the solid mechanics kind of solution and what we're seeing from the finite element approximation. So that's essentially what we are. Okay. So let's check when it comes to the work. So what I'm going to do is I'm going to do a couple of versions of estimating the work. So first off, what I'm going to do is I'm going to look at the exact work estimate, so the stress exact and the approximate strain. So I use the exact stress, but the approximate strain, and see what does that tell me about the work done by the body force. Okay, so that's this strain energy that I essentially have there, that integral. Okay, then sorry, so it's this one here. It's this work exact estimate. So with stress is exact, stress exact, but the strain first model, but this is just the strain we've computed from the finite element. So that's what this strain boils down to. Okay, it's this one here. So it's this line here. It's my estimate, and that's my first exact estimate is to say stress exact, strain, finite element. So the strain has got a small error. So it's not, it's got an error in because when you look at the strains here, they're not exactly the same. Okay. And then we're going to look at what is just the finite elements work prediction. So that is just using the finite element stress and finite element strain to compute the work. Okay. Integrating over the volume of this structure. So that's essentially what we have for that. Then I'm going to say a work exact comparison where I'm going to take the stress exact and the strain exact. So I'm going to take the work, compute it from the finite element point of view, but then I'm going to compute the exact work when I have the exact stress solution and the exact strain solution, and I'm going to compare that to the FEM solution. So those are the two comparisons I'm going to make. So these are two sensible ways to compare, and let's see what we learn from this. Okay, where is that? See at the bottom. Okay, I'll talk about the stress at the end, but for now the work exact. So let's estimate the strain energy. So when the FEM strain energy is this value here, so this is energy units. Okay, I didn't put the units in here, but it's essentially going to be energy units in this imperial system. Then the work exact strain energy, exact estimate of the strain energy. This is now, remember, this is now when I use the exact stress and the finite element strain in that computation. What I'm seeing is exactly the same value. Okay, so the difference in work between the FEM and the estimated exact solution of the FEM solution is 0. Okay, so that's this is the numericals here. So what we see is the consistent node loads. When we use consistent node loads, we're making sure that we get the same answer as what the estimated exact strain energy would be. And what I mean with the estimated exact strain energy is using the exact stress solution, but the approximation for the strain in that energy and that work computation. And those are exactly the same. So that's important to understand. And this is the benefit of using consistent node loads, is that at least the strain energies are related, very relatable to the analytical or the expected solid mechanics solution. So the solution, finite element solution, is very closely related to that for the approximation. Okay. Okay, so then essentially the work done by the centrifugal force is the same as the estimated exact solution. So that's that, and then this is essentially what we just spoke about, that the energies are at least equivalent, and they're relatable. So this is really what the consistent node loads give you, is to make sure that at least overall the structures will see the same strain energies to the sort of estimated exact solution. Okay, then when I look at the comparison for the exact stress and exact strain solution, I'm seeing a 1% difference. Still very, very close. Okay, that is important to understand. So really, really close. And this is essentially even to the exact strain energy of the exact solution of the structure. So at least with its consistent node loads, we're making sure that the strains that we are putting into the structures are at least very relatable to the expected solid mechanics solution. Okay, so that is what we learned from this. And then lastly, what I did included here was also to talk about the stress and to say the largest predicted stress. The stress is about 17% larger in the FEM side than what it is in the exact side. Okay, so it's a bit of an over prediction there. Okay, and then on the tip, we expect to see 0 psi stress, but we're seeing something just under 100 psi. And so that's the nature of the approximation. So when we compare the expected solid mechanics solution to our approximate finite element solution. Now what I'm going to do is, I'm going to repeat the same process. Okay, I'm going to repeat exactly the same problem. The only difference is, okay, maybe before I do that, let me stop the video here so that I've completed the first example. So that maybe